Let's take a look at the power tower defined by square root of 2. So first term of the sequence is 1, and then you get the square root of 2 stacked one on the other to get a sequence. So the sequence would look like something like this. The first term of the sequence, the second one, third one, fourth, fifth, and then so on. So the question is to prove that this is monotonically increasing sequence, and then the second part is to prove that it's bounded by 2. So let's go to the first one. So we want to prove this set of inequalities. So for both of them, we are going to use induction. So the base case. So for induction, you need to prove the 2 steps. So like the usual induction contains of 2 steps. First one is base case. So you want to prove some starting point of this induction chain. So when n is equal to 0, we can easily see that a0 is less than a1, which is a0 is 1, a1 is square root of 2. Or you can do the next step as well, but it's enough, I guess, right? So now let's go to the second step of the induction. So we want to prove that if this inequality is true for n is equal to k, then it should be correct for n is equal to k plus 1. So that's the step of the induction. So we assume that this is correct. So we assume that, say, ak is less than a k plus 1, right? And we want to prove that a k plus 1 is less than a k plus 2. So if this is correct, the second one should be correct. So in order to prove it, so let's do the following. We know that a k plus 1 is equal to square root of 2 to the power ak, right? So each next term is 1 more square root of 2 stacked. So ak plus 1 is square root of 2 to the power ak. And then since square root of 2 is greater than 1, it's like 1.4 something, if I increase the power of square root of 2, so ak is less than ak plus 1. If I replace it with ak plus 1, I can claim that this number is less than this one, because the power has increased and the number is greater than 1. So this one gives me ak plus 2, right? So looking at this intermediate chain of inequalities, I can see that ak plus 1 is less than ak plus 2. So this is true given that ak is less than ak plus 1. This is the step of induction. So basically this one completes the induction. So the first step, a0 is less than a plus 1, and then which means the following. So basically, if I write in a very simple terms the induction, since a0 is less than a1, this one, the step of the induction, says that this proves that a1 is less than a2. Since a1 is less than a2, it proves that a2 is less than a3. And this one proves that a3 is less than a4, and so on. It's just like a domino, goes and goes and goes. So just like if you prove that the first term is correct, the first inequality, and then every next inequality will make this next one correct, so you get the induction. in a very similar way, very similar way, we can prove that the number is bounded above by 2. So what does it mean? So for bounded above by 2 means that for any n, this is less than 2, less than or equal to 2. So if you do the induction in the first step, so 1 is less than 2, or square root of 2 is also less than 2, so the base is correct. So the step of the induction, so if you assume that it's the inequality, the boundedness is correct for n is equal to k, we can prove it for n is equal to k plus 1. So which means, assuming that a k is less than 2, I want to prove that a k plus 1 is less than 2 as well. So in order to prove that, I can just take this inequality, which is I assumed that to be correct, I just raise it to the power of square root of 2, right? So if I raise it like this, I'll get the following. Say, okay, let me rewrite it like this. So square root of 2 to the power ak should be square root of 2 to the power 2, right? And on the right, I have square root 2 squared, that's 2. And this one, you can easily see that it's ak plus 1. ak plus 1. So basically, if this one is true, then this one is true. So which makes the, again, induction step complete, and all of the terms of this number is less than or strictly less than 2. So this number will just keep growing, but as it grows, the speed of the growth becomes very slow, and it will infinitely approach to 2, but it will not reach 2.